This puzzle is called Target Acquired by Sktx. I got it from the Sudoku testing submissions channel of the CTC community Discord. Let's take a look at the rules. So the first one is that digits do not repeat along this diagonal. So this will be a set of the digits 1 to 9 with no repeats. And then the other rule is the equal line constraint. So the digits along every line sum up to the same value. So the green digits are going to add up to the same as the pink digits, which are the same as the yellow digits here. Yeah, it's pretty straightforward. Not complicated in rules, I guess. I don't know how to I don't know how to phrase that. Both rule sets are very straightforward, although they can get to some complicatedness. This puzzle's probably pretty difficult. I'll put a link to the puzzles down below if you want to give them a try. Uh, SK SKTX did say in the post that it was probably like a 4 or 5 out of 5 difficulty, so I'm not sure I'll be able to get through this, but I wanted to give it a try because I really like the equal lines constraint. So we'll see how this goes. Yeah, let's get started. And I will say that I don't know what was happening, but the last 2 times I've started this video, all the other videos I've done have been fine in the past. I've only been doing it like a week or whatever, but um, for whatever reason, even with just this puzzle open and like Google homepage to use as a calculator open, Chrome has shot up to 16 gigs of usage and my whole computer started stuttering. So I hope that doesn't happen. After the first time I shut down Chrome and reopened everything. And then it did it again, so I shut down my whole computer and restarted it. I hope it doesn't keep happening because then I won't be able to record it. Uh, yeah, but sort of on top of that, it means that I have sort of started the puzzle already. I don't know really anything, but I do know one place to look. Um, so let's bust out this handy dandy notepad and take a look. So the thing I saw, and I think it's hopefully the right place to look, is that um, theoretically this could be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, or about that as the minimum, and this would be 7, 8, 9. And actually that would add to 21, so we would have to switch the 6 and the 7s, but that doesn't really matter. Basically, this would be the absolute minimum in, I don't know, in some world this would be the absolute minimum. However, down here we have the exact same layout, and now we couldn't have this happen again because this would be 1, 2, 3, 4, 5, 6 again, and then we would need 7, 8, 9 along here, and now we have 2 of 7, 2 of 8, 2 of 9 along this diagonal. So, whoops, not that one. So we have to kind of, so we can kind of look at these boxes in tandem and see what's going to happen. So one kind of calculation we could do, oh my gosh, it did not remember my zoom sensitivities. Okay, that's really slow. Let's just zoom in with my mouse pad, or with my mouse wheel. Okay, maybe there looks good. Hopefully that's big enough. Maybe that's a little big, actually. I don't know. That might be a little big. Okay. Uh, 4n, yeah. So if we say n is the sum of the line, well, how should I put this, actually? We'll say box 1 plus box 9. Then we subtract off yellow and we subtract off pink. That will equal 4 lines. You can see that pretty easily. We have, the full box here, and we have a full box here. If we take out yellow, we take out pink. Hey, we have 4 lines. That's pretty easy. So one thing to note is what the sum of a full box is, and also the full diagonal, I guess, might be helpful. So every box, row, column, and in this puzzle, this diagonal, contain the digits from 1 to 9 exactly once each. So if we add up those digits, 1 to 9, we get 45. So this box is going to sum up to 45. This box is going to sum up to 45. If for some reason we need it later, this column is going to sum up to 45. A lot of 45s all around. So we can rewrite this as 45 plus 45 minus yellow minus pink, and then that will equal, we'll say just, whoops, come on, 4n. I kept on holding shift to type the n, but then holding it too early and typing it for the 4 instead. Um, so yeah, that just equals 45 plus 45 is 90, so that's pretty straightforward. So now we have this equation, which still doesn't really give us all that much, but we can try to minimize and maximize what n equals, and try to at least get a range. So if we maximize what yellow and pink are, um, to maximize it, if we put 1, 2, 3 here, this will be 4, 5, 6, 7, 8, 9. If we say that yellow and pink have the biggest possible digits possible, um, that'll be 90 minus 39. If you just sum up those digits, I do the opposite. 45 minus 6 is 39, because we know 1, 2, 3 is 6. That's really easy math. And the full diagonal is going to be 45. But yeah, 4, 5, 6, 7, 8, 9 is going to be 39. So that's going to be, what is that, 51? Yeah, one more than minus 40. Then we divide that by 4. And I actually remember this from when I typed it into the calculator earlier. That's going to be 12.5. So we know that, and let's actually type this at the top of the box, or at the top of the thing. We know that n is greater than or equal to, actually let's do it the other way. 13 is less than or equal to n. Because of course we can't have 12.75 be the line total, because that doesn't make sense. So 13 is the highest, sorry, 13 is the lowest it could be. If we did the opposite in here, and we instead put 7, 8, 9 down this middle part, and we put 1, 2, 3, 4, 5, 6 along here, that will be, instead of this number, that'll be 90 minus 21 equals 69. We can divide that by 4, and let's see what that is. I don't remember what that is offhand. Let's 69 divided by 4 is 17.25. With 17.25, which we can round to 17. So we know that this is the range, and we can actually, I guess, yeah, whoops, that doesn't improve anything, because we could have just looked right here and seen that the maximum is 17 for a line, because the most we could put right here is 8 and 9. But we do know, we do have a range at least. And this is as far as I got, was I'd figured out the 17 the first time, and then I restarted and figured out the 13, and now I've restarted. Yeah, now I restart. So now this is all new from here on. But I did notice one thing. Or I did notice one thing as I typed in this 1, 2, 3 in order to maximize pinks to minimize this. That's what gave us the 13. But we actually have a problem here, because if we want this to be 13, and we just put the 1, 2, 3s, or actually we have to go slightly higher than this, but pretty close to 1, 2, 3 in here, we're gonna have a big problem filling this. So maybe let's actually just fill in those digits again and take a look at this. So if we typed in this, and we actually have 3 digits of leeway here, so we could actually replace the 4 with the 1 and then do this. And that would equal 36. The pink and yellow will be 36, so 45 minus 36 equals, no, sorry, 90 minus 36 equals, what is that, 54 divided by 4 is going to be 13. And that's just going to be, one way we could do this. No matter what, this is going to sum up to 9. As just the leftovers from this diagonal. This is now 1, 5, 6, 7. Oh my gosh, that's even higher than I thought it was. Yeah, 1, 5, 6, 7, which is 19. Is that right? We have a 12, 13 plus a 6 is 19. Yeah, so we can't even do 13. We have to do something higher than 13. Now, unfortunately, I don't know how to do this equation. Whoops, keep the colors. I don't know how to do this equation to take this into account. So if we put 7, 8, 9 here, and actually there's a little bit of wiggle room, but basically 7, 8, 9 here. This could be 4, 5, 6. This is at most 16 then. Yeah, so 17 doesn't quite work here. The most we could do here... No, wait, no, this is fine. 9 plus 9 would be 18. Yeah, this actually does work. This does work. Uh, so 17 does work. We could do 2, 4, 5, 6, I believe. No. Wait, what? I literally just had this working. Oh, this is 18. Yeah, this works. Literally works, and I just messed up the math. 6 plus 6 is 12, plus 5 is 17. Yeah, this works. This works. But that doesn't necessarily mean it can't be the answer, because 7, 8, 9 is not the value across here anyway, because we had to round down. Yeah, how can I take this into account as well? That's not helpful. Let's just make both of these pink. Let's just make this whole diagonal pink. And we can make this yellow. I don't know how to take these 2 digits into account. Is there somewhere... I feel like this must be it, because I don't see... There are a lot in columns 1 and 2, actually. But I don't think so many that it will cause problems. Let's see. Let's do some... 17 times 4 would be 68. Just because 51... I know 51 times 17 is... Sorry, 17 times 3 is 51. So plus 17 is 68, which would be 22. 1, 2, 3, 4, 5. That's not even that restricted. This would be at most 6 with 17, but that's not a problem. Yeah, that's... I mean, it's constrained, of course, but it's not a problem. 17 plus 17 is 34, which will make this add up to 11, this add up to 11, 22, this adds up to 23. So this would be 6, 8, 9. This could very easily, with a 7, add up to 17. 7, 5 is 12, and then 1, 4, or 2, 3. Let's do 1, 4. Yeah, even with a 1, that's possible. So how can we figure out... Okay, maybe... Maybe we can end up figuring out what the gray digits are. What these gray digits are. Or what the sum of the gray digits are. So if we do, let's see, 14, 15, 16, 17. So the gray digits are... We have 3 full boxes, so that's 3 times 45. Minus 5 times n. 5 times n equals gray. Is that really just that simple? No, we forgot to subtract off pink. Oh, okay. What? Now I'm confusing myself. Why do we need to why do we have pink on there? Yeah, so it's basically... It's 3 times 45 minus 45, so it's really just 2 times 45. Which is really just 90. And that will give us equals gray. So if we do... we could even try 13 and see what it gives us. Because we know 13 doesn't work, so hopefully this is some value that doesn't make sense. So 13 times 5... Well, 15 times 5 is 75. This one is easy, so this would be 15. So 14 times 5 would be 70, which would be 20, and this would be 25. Which would make this 10 and this 5. Yeah, and 5 is what we discovered. We said this was 2, 3, or 1, 4. So it can't be 14. It's 15, 16, or 17. So these, we don't need to care about those anymore. So 15, 16, or 17. We're definitely going somewhere. Whoops, I keep doing that. Just delete the numbers. We're definitely going somewhere. I just don't know where to go next. We need a map quest. Okay, so actually 17 won't work. 17 won't work. If it was 17, this would have to be 8, 9. Whoops, 8, 9. These digits can repeat, but there's no there's no useful repeating here. This is going to be 8, 9 as well, which immediately breaks. So this can't be 17. So we can remove 17 as an option. So let's just say, yeah, I don't care. We can just change this to a 6. Does it also happen for... Yes, okay. It happens for 16 as well. So if this was 16, now this one can repeat, so we could put 8s here. But then what happens here? We can't put a 7, 8, or 9, so we have to put a 6 here at maximum, and then this is a 10, which obviously doesn't make sense. So it's actually just 15. N equals 15. Oh my gosh. That was that was tough getting through there. But we're 16 minutes into the video, and I've already done the first like 5 minutes twice. So I already knew that logic and had spotted this restriction, so I could just kind of breeze through that. Oh my gosh. Okay. N equals 15. Lowercase n. For whatever reason, that makes me feel better. Okay, so 15. Duplicates don't matter because they're even numbers. So all of these are 6, 7, 8, 9. Oh, which puts 15 on the diag. Each pink section is 15. You know what? One thing I forgot. 15 is 15. That makes sense in my head. It meant gray equals 15. So this is 6, 7, 8, or 9. That's a lot of 6, 7, 8s, and 9s. Does this color serve any function anymore now that we filled in gray? I don't know, but I'm going to leave it open just for a little bit longer. This is also 6, 7, 8, or 9. Okay, that's now giving us a little bit more. Let's get rid of the colors. We now have a quadruple along here. Yeah, let's just start... I don't know if that's helpful. We don't have any other 2 lines that I see, at least. Let's see, maybe we can use this column, these columns 1, 2 that I mentioned earlier. So if this was 15, this would be 30, 60. So these would add up to 30. That's not restricted at all, I don't think. I mean, maybe slightly, but not in any functional capacity. I don't think typing in 1, 2, 3, 4, 5 is helpful. I'm gonna remove that. Okay, how about this? Maybe this is helpful. So this is one pair of the digits 1 to 9. This must be not that pair. So if this was 6, 9, let's just say this. This is 6, 9. This must be 7, 8. And then this must be 7, 8 as well. Which makes the middle green as well. And this blue. I should undo. Let's get rid of these numbers. This is blue. This is green. Now this must be blue as well, because both digits see a green cell. Could this be... Maybe now I need the digits again. If this is 7, this is 8. This is 7, this is 8. This is 7, this is 8. But this could be 8, 7. Although that might be a deadly pattern. That definitely seems deadly to me. We have 8 7s here and 8 7s here. Although I don't really want to use uniqueness right off the bat. I mean, I guess this isn't right off the bat. This is 20 minutes in, but... I don't want to use uniqueness here, but I don't think this can be blue. What about this one? Could this be... No, this sees two blue right here, so this must be green. Let's make this one dark blue, then we can at least see a little bit. I don't know how helpful that is. Let's make this one dark green, which makes this one dark green. One of these is dark green. One of these... I guess this is probably dark green, yeah. But again, we don't know that... Oh, this one can't... This one sees both blues. Yeah, there we go. There's a non-uniqueness way to figure it out. Coloring helps. Actually, you know what, I think... Now that I say that, I think Sktx said that coloring was going to be important. So let's look at this line. Dark blue is not... Wait. Undo, undo, undo. Okay, I messed up this coloring. You probably saw that right away. So does this actually... No, we don't actually know which way this is, besides uniqueness. That's unfortunate. One of these is dark blue. One of these is light blue. No, sorry, one of these is light blue. One of these is dark blue. They can't both be on the line. That's definitely for sure. They can't both be on the line. We have dark blue on this line, which means that we're going to have a bunch of little digits. Even if it's 6, it's 3 digits that add up to 9, which must be fairly small, especially since we already used the 6 on the line. Because if we're assuming dark blue is 6, then we can't do 1, 2, 6 to add up to 9. So these are dark blue and then 3 digits, 5 or less. I guess we know light blue is over here, and that fixes it without uniqueness. Okay. Sorry about that. I just had to mute for a second. Yeah, light blue must be in here because if light blue is also on this line, then we would have, 15 plus 2 digits. So this is not possible. So that wouldn't be possible, obviously. We have light blue down here and dark blue down here. They can't both be on this line. One of them could be... No, but that's going to tie into what we said over here. What was it? Dark blue is going to be like this. Light blue is going to be like this. So they can't both be on this line. One of them's going to be here. Which means... Well... That doesn't really mean much, actually, yet. All it means is that... Well, okay, so here's some... Light blue must be on this over here. I was thinking this would mean something more, like, right away, but I don't think it does mean anything. I mean, because already we knew that only one of them could be on this line, because this line sums to 15 in 3 digits, and we can't have 2 digits adding up to 15 on the line together, of course. So this is light blue, because we have these looking in. So dark blue is going to be one of these. Now we have light blue and dark blue up here as well. That might be interesting. Oh no, I thought I saw something. Light greens come here, but they aren't quite forced onto the line. This could be a light green. Could it be a light? Yeah, because it could... This isn't both spots. This could just be one of the spots. And at most, 2 of these are being used. This one is definitely being used. So at most, 1 of these 4 spots is a blue cell. And in fact, exactly one of those spots is a blue cell, like either dark or light blue. Hmm. Okay. I keep looking at greens like there's gonna be something I can do with them, but I don't. I don't think there is. If we could get two colors on a line, that is a green and a blue, we would know one of them is a 6 because it has to be 6-7 or 6-8 to sum up to less than 15. I do not see where I could do that though. Just stating that I could find such a situation is the easy part. Um, yeah. So yeah, one of these is light green, but that doesn't really mean much. Even if this is light green, that's not causing problems. Could we have two digits on this that are 6 through 9? No, we couldn't. So this is the only big digit on here. Because even 6, 7, even 6 plus 7 would be 13, which would need 1 and 1, and you obviously can't do that. So light green is in one of those cells, one of these cells, and unfortunately we don't know the order here, or else we could at least get like a little bit, but... Well, here's a question. Where does dark green go along this diagonal? Can't go here, can't go here, here, here. Can't go here because of that. Which is going to put dark green onto this. Onto one of these spots. But that does not necessarily mean it's going to interfere with the blue. It won't necessarily be the case where dark green and one of the blues is on the same side. But it is good to know that dark green is restricted up there. Do I need this open anymore? Let's hide that for a second. Did I hide it or did I just... No, I hit the lock button. I don't know what the lock button does. I don't know. I don't really know OBS, but there's a show hide button and there's a little lock symbol. I pressed the wrong one. Okay. So light green. If we knew this was light green, and we know it's not light green actually. So this comes over here. We can't put. We just said this for down here. We can't put two high digits on a 4-cell line. 6, 7 would need 1 and 1. So light green is up here. That's, whoops, this is now dark green. This is now light green. So light green is along here. Unfortunately, that's opposite of the way that we wanted it to work out. Oh, and we know dark green is over here. So one of these is on the line. This is either dark green or light blue. So this can't be light green. Because if this was light green, this would be a minimum 6, 7, 1, 2, which is 13 plus 3 is 16. So this can't be light green. Which puts light green along here. What does that mean? Dark green is into those spots. Because we have this looking over, and then these two looking up. And light green is in one of these two spots. Let's look down here. Dark green is also forced down into this corner. And light green is forced over here. I feel like there's some deductions to be made here. Like, there's just so many high digits on these lines. Because this is effectively another line right here. It's a 15. As is each of these, of course. Um, So if this is light green, or if either of these are light green, if this, what am I trying to say? If either of these are light green, then we're going to have a quadruple here. As long as this is not light green, we have a quadruple. Same with up here. Okay, and actually, where can light green go on the line? It can either go here, because it can't go here or here. Can't go in box 5. So one of these is light green, which is going to force a quadruple into one of the two corners. Could we use Fistamafel ring? So if you, it's a bit of a leap of logic. Not a leap of logic. It's a complicated to prove thing. So I don't even know if it's needed. But effectively, these four corners here. Let's just delete the colors for a second. In any Sudoku puzzle, these four corners have the exact same digits as that ring. And that is a little complicated to prove, and if you're 30 minutes into a solve of a 5x5 puzzle, I'm going to hope you know that. Maybe I'll do a video sometime where I explain that. Simon on CTC and probably Mark too both have much better explanations than I can just whip out right now off the top of my head. So just take for granted that this is true, that light green and dark pink have the exact same digits. Not just the same sums or the same, most of the same digits or something, the exact same set of digits. It's from I guess, I don't know what to call it, like a branch of Sudoku thinking called set theory, dealing with comparing and adding and subtracting sets of the digits 1 to 9. Um, yeah, I don't think it's that hard of a concept once you understand it. I think it's very straightforward, but explaining it well and clearly to someone who doesn't know it, I think is hard, especially off the top of your head. So what was the point of that? Is that could we have we only have one blue over here and only one light blue over here. We have a dark, and so let's see. Well, actually, let me start that over. We have a light blue in 3 corners, so we have to have 3 light blues on the ring, which we have. We have 3 dark blues, which we have here. So we couldn't put a dark blue here, for example, even if this wasn't guaranteed to be wrong, because we can't put a dark blue in this corner. So dark green, we have exactly twice. So we can't use any more dark greens, which I guess we knew because of this dark green and this dark green. So is this actually helpful at all? Let's look at light green. This can't be. This can't be. So all that this can't be light green then. Wait, no, that's not what that means. If this was light green, then we would need 2 light greens in corners. Right now we have 1 light green in the corner, which we already proved because we need a light green on the diagonal. If this is light green, then both of these are in. Which would mean this is in, and this is in, and this is in. And wait, which would mean this is in, this is in, this is in, because we can't double up the diagonal. Which would mean this is light green, which actually looks perfectly reasonable. I don't know my maths, but... Oh no, maybe that's the problem. So if this is a quad, and this is a quad, that means all of these digits are 6, 7, 8, and 9. Of course, I mean, that's how a quad works, a quadruple works. If this was not green, and this was not green, okay, this would be a 6, 7, 8, these would both be 6, 7, 8, 9 quadruples. This is a 6, 7, 8, or 9, because we can't have both blues on the diagonal. Sorry, on the line. We now have 5, 6, 7, 8s, and 9s, which is impossible. Therefore, both of these are not on the line. And in fact, the only light green will be a light green on the line, so this, on the diagonal, so this can't be a light green. Which gives us a quadruple here, which gives us a light green here. I might have to ask if that's true, because I feel like that was maybe a big leap. I really hope not. If this is light green, if I messed up, that's where I messed up, but I'm pretty confident in that. This light green looks down and sees that. This is the last spot for dark green. Yes, which means one of these is a 6. This can't be dark green. One of these is a 6. We don't know which. It could be this is a 6-9 or this is a 6-9. It doesn't matter for the moment. But it means we can't also have this up here, because we said, or I said earlier, that if you have 2 high digits in a set of 3 that add to 15, you have to have a 6. It's either 672 or 681. We have that down here. We can't do it also up here, or we could have just looked at the fact that we already have 2 blues, but I like my way better. So this is like that. We've situated some stuff. This is now a light green, just basic Sudoku. Looking into this box, dark green can't be here. Can't be here. One of these is dark green. I'm sorry, someone has decided to start messaging me on Steam. So it's beeping. Okay, sorry, I think they're done messaging me. They messaged me to tell me that they had an unread message from me, but they didn't see it. That's literally what they messaged me. Very important messages while I'm trying to solve an incredibly complicated puzzle. I don't actually know if I needed the Fistamafel ring. I think that proved that this couldn't be a light green. No, it didn't really. It could have just used this to put it here, and then this is ruled out. So I don't really think the Fistamafel ring really mattered. I don't know. But it did bring my attention to the corners and the constraining quarters. Okay. Oh! Oh, 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 oh! One of these has to be a 6. So this is a... Ooh, excuse me. That was a big yawn or something. This is a 1 or 2. This is... Whoops. This is a 1 or 2. I can do that, of course. This is 6, 7, or 8. This is a 6, 7, or 8. Now, I want to make light green 6, but that's not necessarily the case. These 2 blues could be the same blue. I think. I don't see any reason why they couldn't be the same blue, at least right now. One of these is... No, this is dark green. Because we can look up and look to the left and look to the right. Or to the right and to the left. Light blue is on this... No, we don't know that this is... One of these is light blue. We just know light blue is somewhere in here. Actually, somewhere in here. Sorry, a little bit of a cut there maybe, or at least a little bit of a muted period. Right about 40 minutes. So could this not have a light? Could this not have a 6, 7, 8, a 6, 7, 8, or 9 on it? If it didn't, that would be 5, 4, 3, which adds to 12. So this must have light blue on it. And we know light blue is not here, so light blue is along here. Which actually can't be there because of this. So this is just light blue. This is light blue. So this is dark blue. Which means this is not dark blue. So this is not light green. This is not, sorry, this is not light blue. Well, it's not light green either. It just doesn't make much sense to say that. These are not light blue anymore. This is not light blue. Whoops. Am I wrong? Did I just click the wrong color, maybe? I don't know. So then this is like this. This is like this. This is not this. This is not this. So this line is going to be somewhat constrained because we can't use any high digits on it. But what we really need to figure out is this light blue? Oh, there's a light blue right here. I literally just said that. Unfortunately, that doesn't help the situation at all. I guess both of these colors are the same color. So maybe let's go with dark pink. So this is either 6 plus 7 is 6 plus 7 plus 2 or 6 plus 8 plus 1 because we have the same triple along here. But I don't know which one it is. Maybe you do. But I don't. Let me delete these because I'm a little annoyed by all these numbers that don't make any or that don't mean anything. Oops. 4 really doesn't mean anything. I guess one of these is a 9 for whatever that's worth. So we have a 9 looking over. If that would be a bit constricted. If dark green is a 9, I was just trying to see if we could somehow force this to the dark pink to be involved, but I don't think we can. Dark pink is in one of these two, which puts it here. Actually, maybe we can use it. Oh my gosh. Can't be along here, and it can't. So this is dark. Oh my goodness. Oh my goodness. How is this actually doing stuff? How are we doing stuff with this? I don't know. This is dark pink. Huh. I expected that to be on the line. Wait. That was a messed up. That was a mess up. Because it could be in light blue, of course. We just know it's in the corner. Oh, wait, let me just back up and make sure I didn't do a mess up twice. Yeah, so it can't be either of these digits, so it must be here, which this is the last remaining spot. Now, in box 5, it can't be along the diagonal because of here. Can't be along the vertical or in any cell that's already colored. So it must be down here. And then we have it limited to the corner, so it's on the corner, which doesn't really mean much because a 1 and a 2 are going to be needed on most 4-digit lines. What about here? Doesn't quite help. And here doesn't quite help. Interestingly, no, never mind, I'm wrong. I was going to say interestingly, dark pink is not on this line. Which would, yeah, definitely be interesting, but it's just not here or here. So dark pink would have to be here if it's on the line. Does it have to be on the line? No, if dark green can't be 6. No, but dark green could be 7, in which case the remaining digits add to 8, and at which point we don't need a 2. Right? I think so. I think that's true. I think that's true. And I think also digits repeating could complicate that situation, but I'm not entirely sure on that. Oh, my neck. I don't know if you could hear that. It is stiff looking at the screen. Okay. Light Oh no, this is not light blue anymore. Okay. And these are not dark blue anymore, actually. So dark blue is actually limited to the corner. How did I not just do that basic Sudoku? Again, we have this limited to the line, but that doesn't matter. No, we need oh no, did I mess up? Didn't we say we had to have a, oh shoot. Currently we're putting dark blue right here. And that's broken. Shoot. We said that we had to have a 6, 7, 8, or 9 on this line, otherwise it's 3, 4, 5. When did I make the mistake? Can I rewind it and salvage this solve? Because I'm really liking this. We're broken right now. We're not broken. I think we're still broken because this being dark blue is still forced. So I ruled that out because this must be light blue. Because that's the only spot for a 6, 7, 8, or 9 on this line. Because it can't be here, which makes this dark blue. This is dark blue. Currently, this must be dark blue. I've definitely messed something up several steps back. Okay, let's back up to where we had this. Now, I said this is where I would make a mistake. If I made a mistake, this is where I made the mistake. So what I can do instead, let's look at these lines because we know this must have dark blue on it. This must have dark blue on it, and this must have light blue or dark green on it. So one of these is light blue or dark green. Or both, I suppose. That's another option. So maybe this is light. One of these is light blue. One of these is dark green. This also needs a color. I think that's a fine color to put in. If this is light green, this is light green. This is light green. This is light green. Okay, if this is like, where else can I put light green in the, that's all of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. If this is light green, one of these is light green. Okay, so if we use the ring again, we currently have one light green on here. Oh no, what I tried to say is let me just double check that these are indeed restricted as I thought they were. Yeah, this can't, all three of, everything but light green is forced down here. Everything besides light green is forced into these four. So if we make, both of these quads, if this, if we make both of these quads, so light green is in both of these, I think I did make a mistake. I don't remember exactly what I did, but I think I forced light green in here. Or maybe I forced it here, I don't remember. If these are both fully light green, or sorry, both fully quads, then that won't work. So at least one of these is out. And in fact, exactly one of them is out. Because we can't have both of them out. Because we need a light green on the diagonal. So if this was here, if this was light green, then this would be light green and we would have the same situation where we have two quads. So this can't be light green. Oh, and I think I used this to say this was light green then. But this is just not anything besides these three? Is that true? Is that even true? I don't think that's true. Because other digits could be in there. I think I'm just... The fact that... Yeah, I think they could be empty. Yeah, I think I jumped the gun on that. But this can't... No, this could be dark green if this is light green. So did I reduce any options on anything? Either this is light green, or this is looking down and this is light green. Sorry, I wear glasses and something just like fell on my glasses. It was right in the middle of the lens. So let's try to make use of these lines better. If this line must have a green on it, which means one of these is green, either light green or dark green. I don't think this could be light green. If this is light green, then we're going to force light green here, which puts light green here, and force light green off of here, which is going to put light green here. We're going to have the two quads thing, also problem on the diagonal. So this can't be light green. And we could have also found that by the Fistemafel ring. Because we already have our one light green. So light green must be in here. Therefore dark green can't be on here. So dark green is over here. Dark green's looking up. Dark green is in one of these two spots. Light blue is in one of these four spots. That's not as helpful. If this is dark green, this is light green. Because we couldn't have both of them on the same line. What about over here? If this is dark green, this is light green. If this is light green... What the heck am I buzzing about? Sorry about that. I don't know why it buzzed like super loud there. I think it was like partially touching the wooden table. If this is dark green, if this is dark green, this is light green. This is dark. I don't see how I can break it. Yeah, I think the problem was literally exactly here. I saw these three and thought it was a triple. and that's not true. Maybe I'll cut some of that out, I'm not sure. Because it is nice to see mistakes. I don't mean like in a, what is it, Schadenfreude way? I just mean like, it's good to see the people make mistakes. If this doesn't have to be blue or... Okay. Well, the annoying thing is that mistake really helps progress the puzzle. Um, one of these must be in. Hmm. If this is light green, this is light green. Puts a light green here and a light green here. If this is light green, this is light green. Puts a light green in here and here. That doesn't. Both of those seem the same to me. Let's say this is a blue. Let's say this is a blue. That means none of these are blue, which means these are both blue. Which means this this means this is, if this is blue, then this is green, light green. Because dark green is going to have to be on the line over here then, which means light green must be up here. Which means light green is going to be with a blue. Wait, let's... If none of these are blue... means it must be arranged like this. Is there a problem with that? Makes this light blue. Oops. That actually seems probably right since it leaves a digit on this line. And the other thing, if this is not blue... So the only other option, this is either a blue or it's not a blue. So this is not a blue, does that tell us anything? I guess this is now a triple. And in fact, an actual triple instead of my fake triple down there. Which means this is green. So I think this is never blue. Which means this is not green, so these are not blue. Which makes this, unfortunately, the opposite color. So what happens if we try to make... Oh, if we try to make this blue, of course, it puts the greens on the lines together. So we can just take blue off of there. What if we try to make this blue? So if this is a blue, these are not blue. I don't remember the logic for this. If this is blue, these two can't be blue. Which I said this was dark. Oh no, so these both must be blue. Which then forces the green on the line, which means this is not the green, which forces this to be the green. No, sorry. Forces this not... Forces this to be dark green, which forces this to be light green. And this is on the line. And this is dark green. Yeah, that seems reasonable. Okay, I remember that logic now, so I'll try not to forget that again. Hmm. If this was dark blue, then this is going to be light blue. Then this can't have a color. If this is dark blue, this is dark blue. This is light blue. This is dark green. This is light green. Wow, okay, I'm just stuck here now. Hmm. Can we use this at all? It's on a 4-cell line, but there can be repeats. I think I might have to give up. I'm really not seeing anything, and it's already been an hour, and I've already rewound like a good 15 minutes of work once. Oh, that's frustrating. I feel like I'm so close to figuring something out here. One of these corners, I think I said this earlier, like a half an hour ago, one of these corners is going to have a 6 on it. But blue could still be 6-9 and just have the 9 be here. So that's perfectly reasonable. Let me get rid of these digits. That's not helping me. One of these corners is going to have a 6 and a 7 or 6 and an 8. Yeah. And then this is going to have 7, 8, or 9, and then the opposite corner is going to have something. Does this has to be a green, or this has to be a green. We can't, because we can't put both greens down here. So this is a green of some shade. If this is green, this is green. If this is green, this is green. This is light blue. This is dark blue. This is dark blue. Oh, wait, that breaks it. That breaks it. Oh my gosh. Okay, I think. If this is dark green, this can't be dark green. We need a light blue on this line. So now this can't be dark. So now this is dark blue. No, it's not necessarily. That just means that this is... Okay, well, let's just continue on this logic anyway. Now this can't be either. This can't be dark blue. This must be dark blue. Now we can't have any blues going down here. Can't have dark green. Wait, where does dark green go in this box? What is going on here? Something much more obvious here than I realized. If this is dark green, these can be dark green. Which in fact means this is light blue. We'll forget about that for a minute. These are not dark green. So one of these is dark green. This light blue, however, means that this is circled all the way around, and these can't be dark blue either. Neither of these can be dark blue. This must be dark blue. This can't be light blue. This light blue now looks down. These can't be light blue. And now we can't fit dark green in this box. Because dark green is not here. One of these is dark green. But yeah, so this can't be dark green. Okay. That was a little bit chainy, but, well, I was stuck, so we'll forgive it. This is dark green. This is not light green. One of these is 6, though. This is 1 or 2. This is pink. This is not dark green. These are not... This is not dark green. These are not blue, because we already have both blues on the diagonal. One of these is dark green. That's fine. This looks down. These are not colored anymore. We have dark green on this line. That's fine. This cannot be dark blue. Now we have light blue on this line, so this is dark blue. This is light blue. This is not light blue. This is not dark blue. This is not light blue. One of these is a 6. Do I know for sure that they're the same digit? This is a 1 or a 2, but it could be... If we knew for sure that they're the same digit, then this would be the same 1, 2 as this. If we knew that for sure they were opposite digits, then we would know for sure that light green is 6. I don't know that either one of... Well, I mean, one of those is the case, but I don't know which one is the case. What would happen if both of these are the same? It would go in this box. That's fine. Or so go in that line. Of course it's going to go in the box. This digit is going to go along here, which is going to force it to be in here. Which if it's the same, would force it to be there. If it's different, it could be either of them. Okay, let's see. Is there anything... Oh, this can't be light blue anymore. What? There we go. So where light green is in here? Sorry, my nose is a little stuffed. I'm like 90% over a cold, but like really only mattered to me, I don't know, like Sunday into Monday. But my nose still is a little stuffy sometimes. So apologies for that. We can't limit the dark greens. Down here, don't think we can limit the light greens. Or the light blues, or the dark blues. I think we're in a good state right now, though, to be honest. So we know dark pink is on this somewhere, however helpful that is. Hmm. Well, we can... Okay, we can figure out a little bit about these two digits. This is 15. This is 30. These two digits add up to dark blue? Because this, I guess that's, we could have just figured that out by looking at the diagonal, since this adds up to 15. And we knew that. I can't do it. There we go. So the two digits there, besides the light blue, add up to dark blue. But that could be several options. I mean, even if it's 6, we have 2 options. If we assume this is a different light blue, then this will be on the line here, which is fine. And dark pink will be down here, which could also be just fine. So this digit and this digit, I guess wherever the green is not, down here, plus this, are going to be these 3 digits. I made a step, but I definitely still feel like I'm missing something. So this has so many options here. Could this be a 6? Yes. If this was 6 and light blue. No, light blue can't be 6. Light blue cannot be 6 because 6 is dark blue or light green. If this is 6, it must be dark blue. These 3 digits, that's something. These 3 digits, where do they go in box 3? They can't go along here. These 2 are not yellow because these 3 are not big digits. So they must go on the line with this. Therefore, this can't be dark blue. If this was dark blue, this would be saying 2 of yellow plus dark blue equals 15, but this is saying 3 of yellow plus dark blue. So this can't be dark blue. And actually says light blue is greater than dark blue. Maybe that's important? Where did my... Light blue greater than dark blue. Let's just do that. Yeah, because we can... This cell... Maybe we could do this. Light B minus dark B equals yellow. Which must be like a 1, 2, or 3. Must be a 1 or a 3. Right, if it's 6, 9, it's 3. If it's 7, 8, it's 1. Let me just go over that again. These 3 yellows must be up here on the line. The 3 yellows plus dark blue equal 15. But 2 of the yellows plus light blue equal 15, which means light blue must be greater by this amount. Yes, I think that's all true. Oh, this is dark pink then, because we now have dark blue plus light green plus dark pink equals 15. Now dark pink must be over here, which then puts dark pink right there. Which means dark pink is a 1 or a 2, but not on this line, which means dark blue is not 9, but we already knew that, because we know dark blue is 6, 7, or 8. But if this was a 1, if dark pink is 1, that means this is 6. No, that breaks the puzzle. Okay, let's just go through this. If this is a 1, if dark pink is 1, then we can't use a 1 on this line. The only way that's possible, even if we tried to put a 7 on here, then this would have to be 1 and then 2, 5 or 3, 4. So even a 7 would require 1 because 8 triplets always have a 1. So this has to be a 6, which is fine theoretically because we can put a 6 here. Wait, why did I think this broke the puzzle? This is a 3, this would be a 3, this would, no. Oh, then this would be 2, 3, 4. This would be 1, this would be 2, 4. This would be 9. Why did I think that would break the puzzle? I was sure that that was forcing this to be the opposite of what it needed to be. No, that doesn't break the puzzle. Darn it. I could have sworn that putting this as 1 would force this to be a 3 and force this to be a 6, 9, but that is what it should be. That is what it should be. Darn. Thought I had something there. So we have dark pink up here somewhere. Dark pink down here is on the line with light blue. Which doesn't necessarily mean much, I don't think. I'm not even going to mark that. Dark pink. Oh, I already said that. Dark pink must be on the line. Dark pink must be over here. Dark pink must be up here. So if this is a 2, this could be 6 or 7. Because now 7 could be with... Whoops. Now 7 could be with 1, 3, 4. And this would be a 1. And that would be fine. Yeah, I guess I could say if yellow is a 1, then dark pink is 2, which then would have to be with a 7 and 1, 3, 4. These would be 3, 4, this would be an 8, and this would be a 7, this would be a 6, this would be a 2. That doesn't break anything. This would be 5, 9, this would be the same sum. This would be this sum. What will be used on this line? This would be a 7, 1, 2, 5. This would be 3, 4. That all seems pretty reasonable. The puzzle definitely does feel like it's about to shatter, though. I say that like it's not going to take me another hour to finish the puzzle. So one of these is a 9. One of these must be a 9 because, of course, neither of these are 9. So one of these is a 9, which means one of them is going to be using the other 1 or 2, because 9 has to go with a 6 pair, which has to be 1, 2, 4, 5, or like 1, 5 or 2, 4. Can't be dark pink. Can't use dark pink, so it must be using light pink. So this or this will be using light pink. what does that tell me? I guess there's a 9 down here as well. If this is a 9, this is a 3, and this is the same light pink. If this is a 9, this is one. This is the light pink, and there must be 1, 5. Hmm. So this is an 8 or a 9, as is this over here. So this is 8 and 9, 1, 2, 3, 4, and it must have a 1 and a 2 on it. Right? Because we know light blue is greater. Let's actually write that too. Light blue is greater than dark. Or maybe we can do it this way better. Yeah, light blue is greater than dark blue. Because dark blue requires all 3 of these digits, light blue only requires 2 of these digits. So that makes this an 8 or a 9, which means it's either paired with 6, which is 1, 2, 3, or 7, which is 1, 2, 4. So this always has 1 and 2 on it, which matches up with what we know about dark pink, and also matches up with what we know about yellow. Yellow and dark pink are both on this. This is 8 or 9. Does that help us at all? So if it's 8 and it needs to add to 7, it could be 2, 5, or 3, 4. So dark blue can't actually be 8. So this is 6 or 7. So this is 15, 17, or 6. This is 16 or 17 in total. Could this have a 5 on it, or is 5 always placed? If it's 17, if dark blue is no, this could be more than just 6. No, this is 15. 16. Must this also always be 1, 2, 3, 4? Or could it be 1, 2, 3, 5, 6? Is this just always a 4 or 5, maybe? Which arrow do we need to look at? If this is 6, this adds to 9 without using a high digit. Guess that's something we can look at. One of these is a 6. And it must add to 9 without using a 6, 7, 8, or 9. Which means it must be 4, 5. Right, 1, 8, no. 2, 7, no. 3, 6, no. It must be 4, 5. So one of these is going to be 6, 4, 5. Or 6, 4, 5. I do see if this was a 6, if light... Does that break open the puzzle? If light green is a 6, let's assume this is 6, this is 7, this is 2, this is 1 then. That doesn't really matter though. Important thing is that this must be 6, 4, 5. Now, light blue must be 8, which means it must be paired with 1, 2, 4, and then the 8. We now have a virtual X-wing on 4s, and we can't put a 4 up here. Is that correct? 4 can't be down here because we already, if we tried to put a 4 here, let's say, no, this is going to be 9, 5, and this is going to be 8, 4, 3, theoretically, but then we would have 3 4s in the bottom 2 rows, so green can't be 6, light green can't be 6. Let's go over that again. If this is 6, this is 7, this is 2, which makes this a 1 because it's the difference between 8 and 7. This over here, why do I have this like this? 1 second. This can't be light blue. There's literally a light blue right here. How long has that been sitting? Okay. Either way, clean things up a little bit before we prove it anyway. Why not? If light green is a 6, there's a 6 on here, which means it must be with a 4 5 because it cannot have a second high digit on it. Can't be 1 8, can't be 2 7, can't be a repeat of 3 6. Or 3 with a repeat 6, I should say. Must be 4 5. 6 makes this 7, which makes this 8. That's an 8, which means it must be 1 2 4. We now have too many 4s in rows 8 and 9. Therefore, this is not a 6. Therefore, this is a 3. This is a 6. Jeez Louise, there we go. We got it. We're going. This is not a 6. This is a 9. Take the 4 off. This is a 9. There's a 6 in here. These are a bunch of 9s. This is 4 5. This is a 9. This is a 9. For so long, oh, this is a 6. There's literally a dark blue looking right here. What am I doing? What? So if it's 7, it goes 3. No, if it's 7, it's 3 5. If it's 8, it's 3 4. That's fine. And we have light blue right here. What? Am I just like, I'm too focused on the more advanced stuff, I guess. Which means this is not dark green. And this is not dark green. This is not 7 8. This is not 4 5. This is 7 or 8. Which means this is very restricted. And this is it restricted? So this is, no, we don't know what this is. Never mind. Whoops, wrong way. So one of these is a 3. That's not a 3. This is, yeah, this must be the opposite of whatever dark pink is. We'll just make it light pink. That puts it here, and then up here. So what's left in this diagonal is light pink and a 4 or 5. Okay, but what I saw is really limited. If this is a 7, this is a 3, this has to add up to 5. So it's at most 1, 2, 3, 4, which is very restricted for a most option. And this can't, this is the 6. What? How am I still seeing like basic Sudoku to do with high digits? This is a light blue, light pink. Light pink is on the diagonal though. So we can't put it like right here, I mean. This is a light pink. Yeah, that's not too helpful. So yeah, this is an 8, this is a 3, this is a 1 3. Could this be a 1 3? I don't see why not. I don't see why not. We have a 3 looking vertically here. I guess this is a 1. Whoops, I guess this is a 1, 2, 3. I don't really need that color anymore, but one of these is dark pink. Oh, this must be a 4. Actually, 4, 5 is all that's left in the row. That's the easiest way to look at it. We have a 1, 2, and a 4, 5. No, we have a 1, 2, 3, 4, 5. Which must have... No, it doesn't must. It doesn't must have dark pink. It's dark... It could be a 3. Yeah. Okay. Um... Hmm. Okay. Up here has a 4 or 5, a 3, and a 1 or a 2. Yes, that's how you make an 8. This column is 3, 4, 5 with a 3 required. Should I color the 4, 5s here pretty soon? Maybe. Maybe. So this is light pink, or light yellow, because light blue plus light pink plus light yellow equals 15. So the opposite is dark yellow. So this is dark yellow, this is light yellow. Light yellow's along here. Light yellow's along here. This is the light yellow, light pink, of course, because it adds up to 6 to go with the 9. I like both of those. So, if this is 8, dark pink could not be on this line. Because dark pink plus light green needs a dark blue to equal 15. So dark pink cannot be on this line. Therefore, this is dark pink. Therefore, that's a 3 in the corner. There's a 3 along here, along with... let's make that magenta. And this will be like this. That's really ugly. I really don't like that light pink, or the magenta, the hot pink color. Maybe just make it gray, even though that's a little drab. It's better, yeah, it's better than that ugly hot pink. Okay, this must be a 3. So this is either 5 or 4, and we do not know which one. If we knew this, that would be very helpful, but we do not. Oh, this can't be a gray anymore. So this is gray. This is a 4, 5. Can we figure anything out about this? I feel like there's something in here, but I'm not. Maybe I need to start doing some algebra, but I don't see it right away. What's left in the column is 1, 2, 4, 5, and that's dark yellow, dark pink. But that doesn't give us anything, unfortunately. This is a 3. This is a 1, 2, 4, 5, and it's dark pink, dark yellow. But yeah, we don't know which is which. This must be dark yellow. I say that because these two add to 12. Light yellow, light green add to 12. So dark green could not add to 12 with dark yellow, or with light yellow as well. So that must be dark yellow. This must be that, which is going to give us, I think, a little bit. Maybe not. This is a 4 or 5, and this is the opposite of whatever's on the other side, which we don't know which it is. This line is getting restricted. That is for sure. What's left is light yellow, light pink. So this is a freebie down here. This is, what is this? What is this? This is a dark yellow. This is a dark pink. No, we don't know this has a 4. This doesn't necessarily add to 5. I was just thinking that if this was light yellow, then we couldn't have a 4 over here. But that doesn't actually matter because we don't know that it needs a 4. Or really any repercussions of it not having a 4. Maybe this line. So the minimum here is, if this is if this is 7, then this is an 8, then this is a 1. So these are both these are either both minimum or both maximum. So this is either 8 or 10. If this is 10, then this must be a 1 and a 4. If it's 8, if it's an 8, this must add to 7. This is a 2 or a 3. Yeah, that doesn't matter. Okay, that's not as constricted as I thought. Okay, maybe I need to... If this is an 8, this is a 2. Yeah, maybe I need to do this. If this is an 8, this is a 2. This has to add to 5. This is an 8. This is a 3. This has to add to 4. So that doesn't work. Okay, let me look at this again. If this is 8, then we know this is 7, which means this is a 2. So this is a 2. And this is an 8. Therefore, these two digits add to 5. Also, therefore, these two digits add to 4. We now have 4 digits in the same box adding to 9. And the minimum you can do is 4. If you have 1, 2, 3, 4, that adds up to 10. But we're somehow saying this adds to 9. So therefore, dark green is 7. Which is going to give us a lot of information, actually. Because this is now dark pink is 1. Which makes light pink 2. Which makes light yellow 4. Which makes dark yellow 5. This can't be a 1 then, so this can't be a 4. This is a 5. These can't be 1 or 5. This can't be 1 or 5. This can't be 4. This can't be 2. Okay, so this is 10. This has to add to 5, so this could be 4, 1. This could be 4, 1 or 2, 3. Either of those seem to work, at least at first glance. So this is 8. So this is 7. So this is either 2 or 3. So that means this can't be 2, 3. This must be 1, 4. So this is dark pink. This is a 5. This is light yellow. And that makes this 2. Finally, we resolve the middle pair. Which makes it yellow, which resolves this. These two are dark yellow. This is light yellow. This is a 2, which is light pink. This must just be a 5. I could have done that. This is now a 2, 4. This is light pink. This is not light pink. This is 5, 3. This is dark yellow. This is gray. This is gray. Whoops. This is gray. Which makes this gray. Oops. Okay, and now this is 2, 4. Whoops, that's the wrong color. That's the wrong color. Light yellow. I think I think that's it. I'm gonna take a screenshot of that. Um, I'm really proud of that, even if I made a big mistake partway through with the whoops, where's my mouse? With the triples here, or what wasn't a triple, which is, yeah, clearly that wasn't a triple. Because we have a 5 right there now. Yeah, let's check these lines. Let's delete the colors and check the lines. So 7, 3 is 10 plus 5 is 15. 9 plus 6 is 15. 6 plus 4 is 10 plus 5 is 15. 8 and 7 is 15. 6 and 9 is 15. 15. 15, 15, 15. How many times can I say 15 in the last 5 minutes of the video? 15. 15. 14 and 1 is 15. 7, 14, 15. 4, 6, 5, sorry, 4, 6 is 10, plus 5 is 15. 10 plus 5 is 15. 2, 3, 4 is 9, plus 6 is 15. Is that all the lines? And we haven't repeated anything on the diagonal? If we had repeated something on the diagonal, it would tell us, yeah. Wow. I'm glad I got it in under 2 hours. That was a tough one. That was definitely a tough one. Yeah, definitely like a 4.5 out of 5 at least. I don't like saying 5 out of 5 because I don't consider myself someone who can solve 5 out of 5 puzzles. But so the fact that I solved this, in my mind, negates it from being a 5 out of 5. But this was definitely tough. I really like the coloring with the equal lines. There was one other one a while back. I forget who it was by. Maybe it was the same person. But they had a series of mostly pairs all around the grid, and it was another big coloring puzzle, which was very fun. I think it was like 11 pairs or something, and you all could also use like sometimes they were 12 pairs. It was definitely a mind-boggling experience. But anyway, back to this puzzle. This was great. I really, really loved this puzzle. I really like the equal lines constraint. It's just such a simple constraint, but it has such depth to it that it just makes it such a good constraint to use. Okay, anyway, I'm gonna get some dinner, so thank you Sktx for that puzzle, and thank you all for watching.